All right, hey, welcome back to your favorite pre-calculus class. We'll take a look at slope. And let's talk about parallel lines for a minute. If you have two parallel lines, you know the old joke is parallel lines have so much in common, it's a shame they'll never meet, right? Why? Because they got the same slope. So parallel lines have the same slope. So we'll never meet, right? So if this is a slope of, I don't know, 2/3, this one, if it's truly parallel, would also have a slope of 2/3. Whereas perpendicular lines, let me draw a perpendicular line to this first one. How about in red? Perpendicular lines will create that 90-degree angle. And the slope of the red line that's perpendicular, where they create the 90-degree angle there, would be the opposite reciprocal. So if the blue line has a slope of 2/3, the red line, if it's truly perpendicular, would flip that over and it would change the sign. So if two lines are perpendicular, the product of their slopes would actually be -1. Product of their slopes. That's why they're opposite reciprocals there. And there's actually a very beautiful proof on that. Maybe if we have some time, we can throw that in at the end. But perpendicular lines have opposite meaning the sign changes, reciprocal slopes. All right, so for example, if one slope is, how about let's go with -3/4, the perpendicular slope to that would be +4/3, right? Again, their slope product is -1. Now the general form of a linear equation, there is a general form, ax plus by plus c equals 0. A, b, and c are just constants, real numbers there, and are both, but they can't both be 0. That's a requirement on that. A and b cannot both be 0. Well, find the slope of a line that is perpendicular to, let's do this first example, y equaling -4x minus 3. And let's just kind of get a picture of this before we do this problem. mx plus b. So our slope here, if you know, or I'm sorry, our y-intercept is -3. All right, our y-intercept is -3, our b value there. So in other words, we have the point 0, -3 on our graph. 0, -3. And number 2, our slope is -4. Well, slope is rise over run. So it'll be go down 4, right 1 from there. 1, 2, 3, 4, down 4, right 1. Or if you want to, we can go up 4, left 1. Right? But anyways, here's our line that has a slope of -4. So the slope of a line that's perpendicular to that, let's do it in red, and let's go through that same y-intercept. That would be, instead of a slope of -4, we would have to, we'd have to flip that over, -4/1. I flip it over and change the sign. It was negative, now it's positive. So we would have a slope of 1/4 for any line that's perpendicular. I could have the line be up here. Its slope would also be a 4th, or down here, wherever we draw that perpendicular line. Let's look at this next example. Let's determine whether these lines are parallel, meaning they have the same slope, perpendicular, meaning they have the opposite reciprocal, or either case, meaning they just cross somewhere. Well, if I'm doing the comparison, I'd probably put these into slope-intercept form so that I can see what my slope is. So let's go ahead and put it into y equals mx plus b form and see what our slope is. So let's take that 3x over to the other side. So I get -4y is -3x plus 12. And then let's divide everybody by that -4. And so we've got 3/4 x minus 3. Right? So if we're drawing this picture, I have a slope of -3, and I go up 3, right 4. That would be our line there, 3/4 x minus 3. Let's go ahead and do the next one. We got 8y minus 6x equals 16. Let's go ahead and solve that for y. Put it in slope-intercept form. So we got 6x plus 16. Divide everybody by 8 here. It looks like we have 6 over 8, so 3/4 x, 16 over 8 is 2. So as a y-intercept of 2, it also goes up 3 and right 4. And hopefully you're noticing, oh, they got the same slopes, right? So these are parallel. These lines are, let's make the symbols for parallel. Parallel, right? This is a symbol for perpendicular, of course. Lines are parallel because they have a slope of 3/4, both of them. Find the equation of a line in point slope and slope intercept form passing through -2, -7, but it's parallel to this. Here, let's draw this -5x plus 4. Let's put that on a graph. It's parallel to this. I've got a y-intercept of 4. That b value is 4 there, and a slope of -5 over 1. So I'm going to go drop down 1, 2, 3, 4, 5, and right 1. Drop 5, right 1. Okay, here's the given line. What I'm trying to do is find the equation of a line that passes through -2, -7, and is parallel. So here's -2, -7, okay, but I want it to be parallel. So I'm trying to find the equation of that line parallel to y equals -5x plus 4. Well, first thing I would do is I'd say, well, number one, since the lines are parallel, we know that red line has the same slope as the blue line. Well, what's the slope of the blue line? -5, right? So we know the red one also has a slope of -5 because they're parallel. If they would have said perpendicular, I would have flipped it over and changed the sign, right? But it's parallel. Well, we also know not only is it parallel, but it goes through -2, -7. So that's really all we need to write the equation of this red line. So I'm going to start with point slope form, and I'm going to use this as my x1, y1, and my slope. Slope is -5, x minus my x1 is -2. So I got y plus 7 equals -5 times x plus 2. Go ahead and let's put this into slope-intercept form. Let me come up here. I got y plus 7 is -5x. -5 times 2 is -10. And then we'll subtract 7 on both sides. So we got -5x minus 17. That's the equation of that red line that we drew. Well, let's take a look at this next one. We'll find the equation of a line that goes through -4, 2, but it's perpendicular. Perpendicular to this 1/3 x plus 7. Let's go ahead and draw this 1/3 x plus 7. So I got a y-intercept of 7. I'm going to go up 1, right 3, up 1, right 3, or you could go down 1, left 3, same thing, right? Up 1, right 3, and so on. But we want this line, I'll do it in black this time, -4, 2. So it passes through, here's my -4, 2. It goes through there, but it's perpendicular this time. Perpendicular. Well, we know the slope of the blue line. This slope is 1/3, right? So since these lines are perpendicular, we know since perpendicular, the slope of the black line would be, I'd flip that 1/3 over 3 over 1 and change the sign. So -3 over 1. So that's the slope of the black line. So we have a slope of -3, goes through the point -4, 2. There's our x1, y1. Let's go ahead and plug it into our point slope form. So we got y minus 2 equals our slope, x minus the -4. I'm going to go ahead and just distribute now. And let's add 2. And there's our equation of that black line, -3x minus 10. This next problem is a good you try it problem if you want to pause the video. So here we've got one in general form, not very useful form. I'm going to put this into slope-intercept form so I can identify, and I'm going to subtract x at the same time. 7y, I'm going to identify my slope. So let's put in this useful form. Okay, so my slope is negative 1/7 x plus 12/7, right? So if I was drawing this, 12/7, it's not quite 14/7. It's not quite a 2, but it's here and it's down 1 and it's right 7. If I was to try and draw it kind of like that, there's our blue one. All right, but big thing is we've got a slope of negative 1/7 on that blue line. We're trying to draw an equation of a line that's perpendicular, and it goes through 5. 1, 2, 3, 4, 5. 1, 2, 5, negative 9. And I'm perpendicular. That kind of thing right there. So I go through 5, negative 9. So since perpendicular, the slope of the blue line is negative 1/7. So the slope of the black line, I flip that over 7/1, and it changes from negative to positive. So the black line has a slope of 7. So we know we have a slope of 7. It goes through 5, negative 9. Y minus y1 equals mx minus x1. So we got y plus 9 equals 7x minus 35 when we distribute that. And we subtract 9, so we got 7x minus 44. By the way, the instruction, I should read my instructions here. Here's our point slope form, y plus 9 equals 7, parentheses x minus 5. The next one box down below is our slope intercept form. If I was putting it into general form, I would have to take the 7x over. So subtract 7x on both sides. So I have negative 7x plus y, and I'd add 44 to both sides, equals 0. There's our general form, if you want to put it in general form if they ask for that in the homework as well. All right, let's take a look at this next one. Write the slope-intercept equation of the function whose graph passes through 4, 6, perpendicular to this x equaling 2. Well, if x equals 2, if you're making a table of values, x is always 2. Like, it doesn't matter what your y is. It really does not matter. If you're plotting those points, right? 2, negative 2, 2, negative 1, 2, 0, 2, 1, 2, 2. Anyways, hopefully you'd notice, oh yeah, that's my vertical line, x equaling 2. Well, a vertical line has a slope that's undefined. But if it's perpendicular, one that goes through 4, 6, and is perpendicular to it, I should have drawn my blue one a little further up so you can see that these are perpendicular. Well, the red line would have a slope of, because it'd be perfectly horizontal, right? Yeah, the red line would have to have a slope of 0 then, because it's perfectly horizontal, and it would go through that 4, 6. So now that we know that, y minus y1 equals slope of 0, x minus x1. Well, 0 times anything is 0. So now I'm just going to solve for y. I'm going to add 6 to both sides, and you've got the equation. That's the equation of a horizontal line. Y equals 6. Y is always 6. Doesn't matter what your x is. Y is always 6. So that's that red horizontal line. Well, average rate of change. That's just another way to say that's a slope. We're finding when you're finding the average rate of change of like a line. That's how steep that is, right? So if you're going from x1, y1 to x2, y2, your rate of change, your average rate of change would be the change in y over the change in x, right? We know that that is y2 minus y1 over x2 minus x1. It's that difference in the vertical change, the y2 minus y1, over the horizontal change, x2 minus x1. It's that average rate of change. So again, if you hear average rate of change, think slope. That's your slope. Now in function notation, if this is the point x1 comma f of x1 is your y1, and this is the point x2 comma f of x2, then in function notation, this is just f of x2 minus f of x1 all over x2 minus x1. Again, all of it is a rate of change. It's the vertical change over the horizontal change, that ratio there. So let's find the average rate of change of this negative 3x squared plus 3. And I'll give you a little picture of this. This is, let's get a couple points on here. So if f of x equals negative 3x squared plus 3, this is a quadratic, where x is 0, let's throw 0 in, see what we get. 0 times anything is 0, 0 plus 3 is 3. So I get 0, 3 right there. That's the top of the graph. We'll actually graph quadratics later in the course. Now if x is 2, let's plug that in and see where that point is. 2 squared 4, 4 times negative 3, I got negative 12 plus 2, so I got negative 10. So, you know, and if I could graph a whole bunch more points, but this is kind of what it looks like. And I'm going from 0, 3, down to 2, negative 10, right? And what we're doing is we're just finding this average rate of change right there. We're just finding the slope of that secant line right there in red. That's all we're doing. Average rate of change from there to there. So we have the point 0, 3. That's our first point. And we have the point 2, negative 10. That's our second point. So number 1 was to find the points. Number 2 is to list the points so that we can find the average rate of change, which is our slope. Our slope here, negative, or y2 minus the y1 over x2 minus the x1. So we got negative 13 over 2. That's the slope of that red line. That's our average rate of change. Just sorry guys, I copied this wrong and jacked this up. This 2 right here, that's supposed to be a 3. Sorry about that. Let's change that to negative 9. Let's change this over here. It should be negative 12 over 2. Negative 6. Now here we've got a cubic, x cubed minus x plus 2. And we're going from 1 something to 3 something. So I got to get the points for each of these. Here's our function, x cubed minus x plus 2. So f of 1 would be 1 cubed minus 1 plus 2. Well, 1 cubed is 1, 1 minus 1 is 0, 0 plus 2 is 2. So this ends up being 2. F of 1 is 2. So there's the first point. Now let's throw 3 in. So I get 3 cubed minus 3 plus 2. So I get 27 minus 3 plus 2. I get 24 plus 2, which is 26. So f of 3 ends up being 26. And now, so that's step 1, find our points. Now our step 2, let's find our average rate of change between those 2 points, from 1, 2 to 3, 26. Here's my x1, y1, here's my x2, y2. So let's find our slope. So it looks like we got 24 over 2. So we end up with an average rate of change of 12, right? That's our average rate of change. Go ahead and make this next problem a you-try problem. Go ahead, pause the video and try that. Now check yourself there. Pause the video if you need to. Should have got a slope of a 1/7 on that. If you had a picture, by the way, this is a square root function. You're going from this 9, 3 to 16, 4. And you're finding that slope of that secant through there and draw that the best, but the average rate of change through those 2 points, right? So 1/7. Well, we're going to get into modeling now. Now that we've worked with some linear functions, lots of applications, obviously, for linear functions, and so most of these we'll try to kind of set up in slope-intercept form. Seems to be some of the most intuitive way to think about this. But let's look at this first example. Cost of renting a truck is $20 a day plus 50 cents per mile, and write a linear function for cost as a number of miles driven, x. So x is number of miles. Maybe we'll do it this way for just a second. Y is the cost. So we'll make this a capital C in a minute, but x is the number of miles driven. So for example, let's say you drive 0 miles. So you have no mile charge, but you still have to pay the $20, right? If you drive, let's say you drove 2 miles, well, it's 50 cents per mile. So 2 times 50 cents, I got $1, right? $1 charge for the mileage plus the $20 charge, so that'd be $21, right? If I went 4 miles, well, 4 times 50 cents is $2 charge for the mileage, right? If I only drove it 4 miles, $2 for the charge, but you always have that $20 charge, right? So that'd be $22, and so on. You could keep going with that, get a bunch of points. The reason I'm looking at it this way is I'm like, well, one way to do this is as long as I got a couple of points, I can write this slope, and I have a point, right? And I can write the equation of this. So one way to do that is take your 2 points, find the slope, y2 minus y1 over x2 minus x1, and we got a slope of 1/2, right? Which makes sense. Let me write it this way. It's 50 cents a mile. It's 50 cent charge, 0.5, right? That's our charge. But there's always a charge. Y minus y1 equals m x minus x1. Well, x minus 0 is just x. So let me add 20 to both sides. So it's 50 cent per mile charge plus $20, regardless of how many miles you drive, right? Hopefully that's kind of intuitive, but we do want to write this in function notation. This is y is the output. That's your charge based on how many miles you drive. Right, there's our equation. So however you want to think about that. 50 cents times the number of miles driven, x is miles driven, plus the $20 charge. Let's do step 3. What's the total cost then if I drive 160 miles? Well, let's go ahead and write this out. Let's drive 160 miles. 160 times 50 cents is $80. So if I drive 160 miles, it looks like 80 plus 20, it looks like it ends up costing me $100. If you read through this next one, if I'm thinking about this, you get this manufacturer, you're buying this new machine. Oops. It costs $120,000, but it's estimated that it has a useful life of 10 years. And salvage value of $4,000 at that time. Find a linear function for the value. Let's make this our value after t years. Let's make that. So that's our x and y. T is our x. Value is our y on this, right? So like right here in year 0, it's worth $120,000. It's kind of like a car, right? The car's going to go down in value. It's like this. We got a machine here, but they're saying instead of exponential decay, it just actually goes down in value linearly. So 10 years later, I mean, this is not very accurate as far as 10 years later, it's only worth $4,000. $4,000 10 years later, right? And they're saying this is going down in value in a linear manner. So can we write the equation of that machine that is depreciating? Well, we do have 2 points, 0 and 120,000, and 10 and 4,000. So let's go ahead and find the slope. So y2 minus y1 over x2 minus x1. So we got negative 116,000 over 10. So negative 11. So it's, you know what? Let's think about that for a minute. So it's dropping $11,600 per 1 year, right? It's dropping that much money per year, right? That's what that slope means. Losing $11,600 of value every year. We want to find the linear function, so we take our slope, we take one of the points, and we can write it in. You can use point slope, or you know what? That's our y-intercept anyways. Let's just throw it right in. 11,600x. Our y-intercept is 120,000. Except we're supposed to be in t's and v's. The value of this after time t. So the value of it after time t. There you go. You could find, if you wanted to, you could find the value after 11 years, whatever, right? Or 5 years using that model. Well, we've got a company here and they're manufacturing a product that they've got fixed costs, and it's telling you how much it'll sell for as well, right? So fixed costs, in other words, to produce the product. It says, well, what's the profit? Well, our profit is going to be whatever we get in revenue, right? Because we're selling these items, minus our costs. So here, let's do it in function notation. Let's look at that second sentence. The fixed costs. Let's go to the side for a minute. Fixed costs will be $500,000 and $400 for every item. Let's call each item, each product. Each product is X. All right, so if we produce one item, it'd be $400 times 1, 400 times X, plus the fixed cost, 500,000. Like maybe your fixed costs are like employee salaries and rental for the warehouse and stuff like that, right? Like you have fixed costs for that, and then you know how much, and then you got $400 every time you build it. So maybe that's, I don't know, energy on your machine or whatever it may be, right? But that's your costs. That's your cost. So C of X is 400x plus 500,000. Now, what about our revenue? Like how much do we make on this? Well, we sell each of these. We definitely got to sell for more than $400 because it's $400 just to make each one plus the fixed cost, right? So it looks like here they're telling us you're selling them for $600 as your revenue coming in, right? So let's go over and see our profits. What's the profit equation? And then we'll figure out how many we got to sell just to break even. Okay. So our profit would be, well, we're selling them for $600 each minus the entire costs, right? Now don't forget, you got to put this in parentheses because there's two terms there. So our profit would be $600 each minus 400. Go ahead, combine like terms. So we get a profit equation of 200x plus, or I'm sorry, that's supposed to be a minus right there. Bless you. Okay, there's our profit after selling X amount of items, right? Now, to break even, you know, how many do we got to sell to break it? Well, you know what? Let's do a little picture of this. I'm way down here, negative 500,000, but I'm going up $200 per our slope, right? We're wondering, this is X, this is our profit, P profit is our Y axis, our vertical axis, right? We want to know this break-even point, right? We're running negative for a while until we sell so many of them, right? Well, what's our Y value right there in red? 0, that's our profit. That's our Y value, P of X. So make P of X break even. Oops. Break even, my profit has to be 0. This is my break even point. How many do I have to sell to break even? Let's add 500,000 to both sides. And then let's divide by the 200. And that should be 2,500. That's 2,500 units. So we got to sell 2,500 of these just to break even. Right? That's the break even point right there, 2,500. So if we sell more than that, we're making profit, right? That's a good thing. We don't want to sell less than 2,500. We're not going to be a successful business. Well, thanks so much for taking notes, and we'll see you next time.